Okay, so this is going to be part one of our tutorial on developing a 3D model of a single living unit for project 4, and uh, and then developing an axonometric drawing, kind of X-ray style drawing from that 3D model. What I want to do in this video is, without showing you the whole process, walk you through a bunch of 3D modeling techniques that I think you'll find useful in developing this model of the single unit. And I think starting out with that, it would be really helpful to begin before you develop a 3D model, at least develop a set of plans. So here you see a set of plan drawings of a single living unit, first floor, and then like a loft space up above, as well as, if you can, and maybe this is something you develop more as you develop the 3D model, but you can also developing interior elevations, section elevations, etc., to begin to describe where things like windows, floors, even things like furniture and so on are existing. So I'm going to work from this digital set of 2D drawings that I've taken, and these, by the way, were developed from a project called the Convent Studios by Rick Joy. It's a local project here in Tucson, Arizona. And they're these kind of simple, small living units, a single kind of living space, kitchenette style kitchen, a loft, sleeping space, and bathroom up above. So very kind of simple, straightforward living units, but really kind of beautiful quality. In fact, these units are actually in the barrio where your project's sites are. So anyway, so I'm gonna kind of work just using this precedent. I'm going to develop a 3D model of this precedent and show you how to make a representational axonometric drawing. So I have the drawings, like I mentioned, and they're not line weighted or composed or anything like that. They're just to kind of give me a base to begin to develop my own 3D model from. And so what I'm actually going to do before I begin, first of all, I'm going to start drawing on a separate layer. So I'm going to start making my 3D model on a separate layer. That way I can keep these line drawings kind of in place in order to reference them as I need to as I go along. But I'm also going to begin to like reorient these drawings in 3D space so that I can really use them to line things up and get the heights of things and so on and so forth. As I mentioned, my first step will be to start to reorient some of my drawings, these interior elevations, in 3D. So I'm gonna work in top view, and I'm just going to tilt my view into axonometric. The other way you can get there, of course, is going to the display options in your viewport, go to isometric and click on one of those. And that way we're in a 3/4 view, but we're also in a paraline view. So we're looking kind of in axonometric, but we're not looking in perspective, and that makes it a little easier to navigate, in my opinion. So I'm going to start by kind of orienting these drawings in 3D using rotate 3D. They were kind of similar operations to what you guys developed first in project 3. And at the moment, I'm just going to leave them off to the side, because what I really need these drawings for is to give myself a sense, or to give myself kind of an indication of what height things are going to be at. And I'm also going to do this big elevation on the other end here, which, as you can see, is kind of oriented off to that direction, to use as a reference point, because, and I'm just going to delete my construction lines, those now. I can always draw them again if I do need them. But that's going to make it a lot easier to, because this one's like lined up to my drawing, basically. Yeah, so this one's like oriented to that tilted wall, and this one's oriented to the straight wall. It's a little easier to work from. Okay, so I'm going to make a new set of layers, and the first thing I'm going to do is make a floor. Now, I think it's important actually, before I even do that, I'm going to make a 3D layer. I'm going to put everything 3D on there. I'm going to put everything 2D on a separate layer. And that's just going to be, these are my drawings. And these are the images that I pulled the drawings from. I'm going to lock that stuff for now, just so I don't mess it up. Okay, so I'm going to work on my floor. The first thing I want to do is begin by drawing a kind of floor plate. And I think it will be important. Oops, did not mean to do that. I'm going to use the Polyline tool. But I'm going to begin by drawing a floor plate. And I think it will be important to represent thickness in these drawings. But I don't think it'll be important as much to really show the full detail of how the building is constructed. So for example, I actually have the kind of like formwork lines just because it helped me figure out the scale and dimension of certain things. But we're not going to put that kind of information in. We're really more interested in what's the kind of interior living space and everything that makes it up, the furniture and the built-in stuff and the windows and doors and all that. Anyway, so the first thing I'm going to do is I'm going to make a polyline. Now you can see that's a closed polyline. And in order to make that into a surface, I'm going to go over here. And this is under my 4-point surface tool. And I'm going to make a surface from planar curves. It's also known as planar surf. I'll select that outline. And remember, you need these outlines to be closed. So they need to be a closed curve. And it needs to be a planar curve as well. And if I throw my view in shaded there, you can see now I have a surface where the ground plane is, which is great. Like I said, I want to represent the thickness of things. So I'm going to go ahead and extrude surf. Why can't I? Go. And I'm just going to make it like 6 inches. Again, I'm not terribly worried about what the thickness of things actually is. I'm just going to start by modeling things as kind of like mass, as kind of thickness. And then when we get further on into our line drawing, or sorry, into our axonometric drawing, that's when we'll start to edit which lines we're actually showing and which ones we want to remove to clarify what we see in some of these drawings. So the next thing, once I have my floor in place, I'm going to start to model my walls. I'm going to give myself different, lines here, different layers here, different colors, and I'm going to do actually the same exact thing I just did to make that floor. So I made a closed outline that is the outside of the wall. I'm going to select both those lines at the same time, and I'm going to make a planar surface. And as long as they're coplanar and as long as they're both closed, and I'm even actually going to delete them there, it should make like kind of a surface between them, which is perfect. And what I'm then going to do is, again, even though we only really care about the interior, we do want to represent some of the kind of mass of the building. And if we look at the section of this, and this is just something that's kind of typical of this style of construction, we see the walls go a little bit deeper into the ground, and they have a kind of concrete footer foundation that they rest on. And the slab is kind of poured within the walls. So the floor, in other words, is poured kind of within the structure of the walls. So what we know is that the wall is going to begin below where the floor begins. And that's, again, I don't really care where. I just want it to be a little bit accurate in my representation. So I'm going to move that guy down just a little bit. Now, if you're wondering how I did that, there's 2 ways. I can go move and choose the option vertical. And that constrains me to the z-axis as long as I'm in top view. If I'm in front view, my z-axis is going to go back and forth in that viewport. So you see where my plane is there, it's going to go this direction. But as long as I'm in top view, it's going to move in that direction. I can also drag and hold control on the keyboard. Same thing, it's going to move it only in the z-axis. And then when I'm ready, I'm going to go extrude surf. And this time I'm going to make sure I have that option solid set to yes. And I'm going to extrude all the way up to the top, the highest point that I know that my wall is going to go. Which will be the high point of that interior elevation. I'm actually just going to delete that original surface. Okay, so that's basically how I'm going to work. I'm going to work by making solids, and then as I work my way through and do the windows and doors and so on, I'm actually going to subtract from this solid, much like you did with project 3. So now I need to begin to start to trim away my walls. Now I need to trim away like along this plane, right? So an easy way to do that, I'm going to make a line, just a polyline or a line, either one, along that edge. I'm going to select that line and type extrude curve. I can also extrude curves. In my options here, you can see, for one thing, it's extruding in both directions. I don't want that, so I'm going to turn the option both sides off. Solid is turned to yes, but because it's only one line, it won't do solid. So we'll just leave that alone. And the other thing that I want to do, I want to extrude this in that direction, so it's going through my wall. I'm going to choose this option, direction. And then it's going to say base point for a direction. I can click anywhere, and then I'm holding shift, and I'm drawing straight out. So shift to snap to ortho, drawing straight out, setting a second point for direction. So I'm setting basically like a direction that I want the extrusion to go. If I don't have a curve that's like kind of planar, which a straight line, I mean, is technically planar, but it's like, it's not enough information for Rhino to know what direction I might want to extrude it, so it just extrudes it in the z-axis. So I can move it. I can change that direction by using that option direct. So now we have that plane kind of where we want it, but the issue is that it's not going all the way through my wall. So this is also something to kind of be mindful of. For example, if I tried to trim it right now, it wouldn't work, right? Anytime I want to trim a surface, it has to, the object I'm using to trim has to go all the way through that surface. So how do I make this plane bigger? I'm going to use scale 1D. There's all different scale. Under transform, there's all these different like, move, copy, rotate, things we're familiar with. And then under scale, we have a couple different options. Scale 1D is really useful because it allows us to make something longer but not wider and so on. I can kind of drag it out that way. Now you can see that plane goes all the way through my wall. You can also see that I didn't quite extrude my wall high enough. I'm going to scale 1D my wall as well. Go. And when I did that, I just snapped to the edge. Oops, that time I didn't. I just snapped right to the vertical edge of my wall because I know that's, straight up and down. And so if I scale it according to that dimension, I won't distort my shape in a weird way. Okay, and now I'm ready to trim my wall. So I'm going to hit trim with my trimming plane selected and go ahead and trim away that wall. Now if I delete that plane, what you'll see is the inside of my wall has become open. See that? And I can actually look down into where that drawing is and see that. Now, what I want to do is avoid having an open wall like this, or an open polysurface. So when you make a polysurface in Rhino, polysurface is simply just a collection of joined surfaces. And what makes it closed is that the joined surfaces form a closed volume, right? So if I explode a polysurface like a cube and delete one of the faces, now I have an open volume, right? And in fact, I don't even have a polysurface because I've unjoined, much in the way that when you unjoin a poly curve, you get just a set of, or polyline, you get just a set of individual lines. I have a polysurface, and now I can kind of look at the individual faces and deal with them individually. And any surface that's joined along an edge, any two surfaces that are joined along an edge, or touching along an edge, I should say, I can join together and make a polysurface. So how do I close this again? There's a couple ways I could do it. One way I could do it is I could use that trimming surface that I made, and I could trim it. So now I'm selecting my wall using the trim command and trimming away that trimming surface. Now you can see it's still a separate surface. It hasn't been joined to my original wall, so my original wall is still open. because if we move this away, you can see that wall is still open on the inside. If I select them both at the same time and hit join, then it'll be one object. My wall will not be open, and you can see up here it says closed poly surface, which is what I want. I want to keep everything to be a closed poly surface. It's going to make my life easier later on. Okay, the other way I could do it is anytime, oops, didn't mean to do that. Anytime I have a planar opening in a poly surface, a single planar opening, which this is because we trimmed it with a planar surface, I can also use a command cap. Cap will close any open poly surface by applying a planar surface to any planar opening. So much like just when I exploded this cube and deleted one of the faces, if I were to join these guys together and cap them, it would create a closed or a surface where that planar opening was in order to close the object. And if it can't close it, it'll tell you. It'll tell you up in the command line, error, couldn't find planar openings or whatever it is, you know. Okay, so there's my walls. That's great. And then I'm also just going to add a roof, which again is just going to be a plane. Now, I could have used that same plane that I drew before. I can also draw a plane in another way. With a surface like this, I can use 4-point surface, and I can trace out the corners of my volume there, and I can create the plane that would be kind of the roof surface of this volume. And I can extrude that thing. And again, like I mentioned before, because this is actually a planar surface, you can see it's extruding it, you know, in the plane of the object. And once again, I can just reset the direction of that. And I'll just give it a little bit of thickness. We don't really care too much about what that roof is. I'm going to set that to another thing. Okay. And I'm going to turn it off for right now. I don't need that. Okay. And so now I'm in a good place to begin to subtract openings that I need to create the windows and doors in my volume. And so I've traced out in my elevations, in my interior elevations, where those would go. So what I want to show you is a couple of techniques for creating those openings. I'm going to start with this window right here. This is actually like a, actually let me just show you the image of it. There you go. So it's actually like one big opening in my wall. So what I'm going to do is I'm going to punch that whole hole into my wall. And then I'm going to come back in later and I'm going to add this like window framing as a separate layer. That way I can show it independently. But for the time being, I'm just going to go ahead and I'm going to just punch the openings where the walls would, or I'm sorry, where the windows and doors would go. And then later in, I'll add the detail of the window framing and stuff like that. So I can do kind of the same thing. I can make polylines. I'm going to still working on my wall layer because I'm just, basically I'm still developing what my wall is going to be. I'm still making like the cutouts and everything like that. So I can extrude this guy, and I do want to make sure that I'm making it, that it's the option solid is set to yes. So one more time, that option solid set to yes, and that means I get a closed poly surface when I do that, when I extrude that guy. Okay, and now what I'm going to do is I'm actually going to move it in to where my wall is. And I'm going to move it so it's going all the way through my wall. And I'm going to use this volume just like I did earlier with my, or sorry, in project 3 when we did our kind of volumetric subtractions. I'm going to use this to do a Boolean difference in my wall. So I'm going to type in Boolean difference. I'm going to set the delete input to yes. And I'm going to select that volume to be the one I want to subtract. And what's really nice about that is you can see it keeps our wall as a solid, closed, you know, kind of watertight polysurface. So it makes little surfaces on the inside of the wall where the cutout would be, and that's appropriate because that's kind of what the wall would be in reality, right? It's all solid mass, and I'm making these kind of punch outs. So I'm going to continue and do the same thing for the rest of these guys. And when I do them, oops, why did that happen? So I can also just use this option rectangle the command rectangle and use the option 3-point. Extrude that. I can even actually just go like this, go all the way through it. Doesn't matter, as long as it intersects. That's where I want my cutout to be. That's great. Same thing, 3-point. You can see on my elevations, I drew where my window frames would go. But at the moment, I'm not concerned about that. I'm tracing the outermost outline, just trimming that wall, okay. One other thing I want to show you, because this starts to get a little bit tricky, I'm going to go into a wireframe for a second. Let's say we have a cutout in our wall that isn't just a straight extrusion. And that exact thing actually happens here in this project. Look at this. There's 1 second. Okay, so we had a line we didn't need there. Okay, so we can see right here that this cutout, this little window opening in our wall, is actually not it's not a straight extrusion. It's like a tapered volume, and we can see on our interior elevations where that little guy goes. So I'm going to do the same thing with this. I'm going to rotate this drawing vertical so I can use it as a reference point. And then I need to kind of figure out, okay, how I'm going to make a volume that's this shape in order to trim away, not just a straight planar extrusion. So I can do that a couple different ways. First, I'm going to start by taking this outline. I'm going to extrude it through the inside, I should say, beyond where it intersects with my wall. Instead of just trimming away my wall, what I'm going to do first is I'm going to select that extrusion in the wall, and I'm going to go intersect. And that's going to give me a curve where those two polysurfaces intersected. So we can see that I have a curve right there, and that's basically going to be the size of my opening there. Now, if I were to draw a line up vertical from my plan, I could figure out kind of where my secondary outline needs to go. So I could go scale. Again, this is just regular scale, so I'm going to scale 3D basically. Now to find the center point, I can do center. I believe I can do center. There we go. If that doesn't work, I can also go, I can just draw the line as a reference point. Oops, I did not need to do that. If I draw a line through from midpoint to midpoint of that rectangle, then I know the midpoint of that line is the center of my rectangle, and I can scale it 3D like that. So now I know that's the size of the cutout on the other side of the wall. Now I figured that out earlier in my drawing, so I could have just done the same thing and extrude that guy and found the intersection between the two polysurfaces a second time. But that's another way to do it. So what we want to do is kind of map out on the surfaces of our wall where those outlines the outlines of that cutout would be. Now, in order to make that into a surface that I can then do my Boolean subtraction, I'm going to select both and I'm going to loft them. Now, when you loft, in fact, let me just isolate these really quick. So I'm going to select those two and type in isolate. Isolate just hides everything except for what I have selected. So if I'm in shaded, I'm going to select these two outlines and go loft. Now, when I loft to planar polylines like this, a couple different things need to happen. One of them, I want to go straight sections under style, because that way it knows that I want to loft one edge to one edge and the other edge to the other. And then the other thing, I guess I don't have the option to do a closed loft. So I'll just loft them like that. That's kind of what we want. We want that kind of tapered, truncated volume. You can see it's open on both ends, so it's not going to work to do a Boolean. So I'm going to select that, and I'm going to type in cap. And because those openings are both planar, it should close the poly surface and add two little end surfaces. To get everything that I hid back when I typed in isolate, I'll type show. So I'm going to select the wall, Boolean difference, select the cutout. And so now it's become like a subtraction from my wall. Actually, you know what? Before I do that, in order to be efficient, I know I have another cutout up here that's the same. I'm going to make a copy of this guy before I do my subtraction. So I'm going to copy it. I'm going to constrain it to vertical. Move it up to where that guy is. It's also actually like, rotated. Use my gumball. Rotate it 180 degrees. Like, in other words, the smaller cutout is on the inside of the larger cutout is on the outside. So, and then I'm going to move it over to line up with the cutout on the second floor. So I'm using the move command. I'm clicking it, and in order to move it in the direction I want and also line it up with the edge that I need to line it up with, I'm going to hold Shift and hit Tab. And when I hit Tab once, you can see my motion is constrained to that direction that I was going when I was holding Shift. Then I'll go ahead and click on the object I want to line it up to. And now it should be pretty well lined up to that guy. Okay, and so now I can do Boolean difference with both of these. And I get those kind of truncated openings. Cool. So I am going to go through and do the remainder of the subtractions using the same exact techniques. And then I'll return to this video when it's time to start modeling other things like the floors and the kind of furniture, the built-in stuff. So I'm going to pause really quick, and then I'll return when we're on to the next step. Okay, so actually the next step, now that I have all my cutouts in place, is to draw the kind of window frames that I talked about earlier. So I'm going to make a new layer for that. I'm going to call it window frames. Give it a different color. What it is. Okay. Now, what I'm actually going to do, the best thing, or the easiest way I think to do this, is to make a kind of box at the inside of my window frame, and then offset everything based on that so that I can create the kind of thickness of the framing and so on and so forth. So actually, instead of make a new box for every window, I'm going to copy my existing wall and explode it and start to make my window frames based on that. So I'm going to select this wall. I'm right-clicking on window frames, and I'm going copy object to layer. I'm making a copy of it. Now I have two walls, right? And when I turn off walls, if I hide that layer, or I just use the hide command, either way, now I have a duplicate of that wall. I'm not like losing work. So just make sure that you don't, move it to a different layer and start messing with it without copy. So now I'm going to select this object, and I'm going to explode it. I also turned off my drawing layers because I don't need that stuff right now. And I'm basically going to delete everything that is kind of the surface of the wall. So like we talked about before, when you make solids in Rhino, they're just composed, they're just joined polysurfaces. So when we explode it, we can kind of delete whatever we don't want, and we can keep whatever we do want. Now keep in mind, these are all unjoined individual cutouts. I'm going to select them all at the same time and just type in join, and it'll look for anything that it can join and join it. So they're all now rejoined cutouts like that. Okay, and so like I mentioned before, what I want to do is model those window frames And if we look at the actual building, the window frames don't go all the way to the outside surface. So one thing we have to do is before we start to model the window frames based on the surface, and I could actually turn my walls back on to give myself a point of reference here, I'm going to start to scale these guys back. So I'm using scale 1D. I'm scaling, sorry, I should be scaling towards the inside of the volume. So I'm scaling on an inside edge like that, and I'm going to my midpoint, just like that. So in other words, that represents the outside surface of one window frame. Once I know where that is, then I can use the command offset surface. And within that command, I'm going to make a surface that has a thickness that's closed. So the first option is the thickness of that surface that I want it to be. So I'm working in inches at the moment. I'm going to make this window frame 1.5 inches. I think that's about right. And I'm going to turn the option solid to yes. The other thing that might happen is you see these arrows here, that indicates the direction the offset's going to happen. I can click on it to go the opposite direction. And when I have everything set what I want it, where I want it, right, the way I want it, I'm also going to have delete input set to yes, so I don't have that original surface as a duplicate. And once I'm ready, I'll hit enter. And voila, we have a window frame. So I'm going to do the same exact thing for every single other frame, except for a couple which actually don't have window frames. These guys are built in a slightly different way. I'm going to go ahead and just delete those right now. But anyway, so I'm going to go through, scale these all back, and then you can actually also offset them all at the same time. Okay, so I could select them all at the same time, type in offset surf. They should all be going in. If we zoom in on them individually, we can kind of see what the arrows are really doing. But they should all be facing in. They're all going to be offset the same distance, and they're all going to be solid. So I'll go ahead and hit enter. Like that, we've modeled all our window frames. Pretty quick and easy. Okay, and then the couple that we have that are a little bit more detailed than that. For example, if we look at the plan drawing, we can see that a couple of these windows are operable, or in some of those like 4 square windows, we have a little operable panel. One of them is operable. So we can go ahead, in those cases, we can add like a second, that's a good example right there. We can see that one that's right above the kitchen island has like a second frame within it, and that's got a little hinged thing, and that's an operable window, right? So in those particular cases, we're going to actually model a second frame. Now, let me show you how to do that. I'm actually going to do the exact same thing I just did, which is I'm going to make a copy of this guy. In order to copy it where it's in the same exact place, I'm going to type in the command copy, and I'm going to hit the option in place. So now I have 2 of the same surface there, right? I'm just going to hide one, typing in hide in the command line. Same thing as before, I'm going to explode this guy. And I'm just deselecting, so I'm holding Control, deselecting the inside surfaces, delete the rest. Same thing as before, join and offset. Sorry, offset surface. And I'm going to use the same, I'm going to use a different dimension for that. Oh, and actually, sorry, I meant to also scale it, but I can do that later on here. So that's a thinner because it's just a frame for that operable part. And again, there'd be a little bit of trim, like there'd be an edge where this window has some, where it's sealed because it's operable. There might be a frame where there's a screen. We're not going to add that level of detail. We're just going to do enough that it's sort of clear. If I type in show now, I'll bring back that window frame. We're just going to add enough that it's kind of clear that that is an operable window. Something like that, yeah. Actually, I'm going to keep it right on the same edge, but anyway, like that. Now to do these guys, we're going to work it a little bit different because we need to first trace out where those subdivided surfaces would be. There's a couple ways we can do that. We can make new, maybe I'll make a plane first, just a single plane. I'll go midpoint to midpoint. So I chose the option plane vertical. If you just type in the command plane, you can do 3-point or vertical either way. So if I'm doing my horizontal guy, I'm going to go 3-point. I'm going to go midpoint to midpoint or midpoint to perpendicular on the inside edge. Snapping the perpendicular over there. So I've made a plane at the thickness of my window frame from horizontal from one edge to the other. And I'll do the same exact thing. Vertical, I'm going midpoint to other edge, perpendicular. So now we have a single plane, and we can do the same thing as before, offset surface. This time I'm going to use half the distance because I'm going to offset both sides in both directions. Because that surface where we have it currently is right in the middle of where we want that crossbar to go. So I'm going both sides, setting my distance to 0.75, and I'm keeping the option solid set to yes. And there you go. So you can see it offset in both directions there. See that? That's what we want. Offset surf. Oops. And didn't change any options, did the same exact thing. I'm going to do the same on this window. So I'm going 3-point plane, using my midpoints and my perpendiculars, vertical plane. Same thing. And I can offset both at the same time, actually. So I'm half the distance, and I'm going both sides. There we go. So there's the rest of our framing. And then the other way we can make this little kind of operable portion, which is in the lower corner on each of these guys. We can also just model a little box. So it's less easy because these are actually going all the way through each other. Get that interior surface like we were doing on the last window. What I'm going to do is I'm going to make that interior surface by modeling a box. I'm going to start with 3-point on this guy because remember this wall is tilted. Tracing out that interior volume. Great. Explode. And then deselect the planes and join the outside. So now I have a surface that's that inside that I want. One more time, explode. I'm holding control and I'm clicking on the two flat faces to deselect them. By the way, if you have trouble like that, where when you orbit, things like fly out of your view, like that, like that. What you can do is just quickly go zoom or Z, enter, and hit the option selected or hit S, enter, and it'll make that object the center of your orbit. So you'll see me do that a bunch. I actually have a hotkey for it. And that'll just, kind of make it easier to navigate as you're going along. So anyway, deselect the flat faces, the ones in plane of the window. Join the inside edges, delete. So just like before, I'm going to offset these guys. I'm going distance 2 inches. That's what we did over here. I have, oh, and you see, so now, because of the way I modeled this, the arrows are pointing out, so I just need to click on each one to flip them, flip the direction that they're going to offset. And that's it, press enter. Here we go, and then I'm just going to scale 1D these guys so they're the same. I forget what I did over here. What was it? Distance. Some random, it should have been 2 inches. Scale 1D, 2 inches. Scale 1D. Nope. Just like there where it moved out of my view when I orbited. Just go in Z, enter, S, enter. You can see it doesn't even cancel the command when you have a command running. It's just going to recenter your orbit. So right there, Z, enter, S, enter. Scale 1D. Go into that inside edge, just typing 2. So I'm clicking on both ends, typing the dimension I want it to become. Cool. And then I suppose I have to, so I messed up actually on this door frame because we don't have a little like sill there at the bottom of the door. It's just the wall, or the floor, I mean. Oh, actually, I just realized I did something wrong. So I'm seeing that those window frames are actually tilted. Is not the way I modeled this. So let me show you another way to fix things. It's a little bit complicated, but I think you guys will be fine. So let's say I wanted to make these cutouts, rather than being sort of perpendicular to the plane of the wall, I want them to be straight up and down like that. So I'm going to start with just the wall, editing the wall. So by the way, there's a bunch of, this is what's called a hole. There's a bunch of ways to edit a hole. I type in hole, right. So you can see I have an option, move hole. I can select this guy and, right, move hole, move it around. Not exactly sure why it's not working, but anyway. Okay, that's weird. Oh, I think it's because that one's on the edge of the, should work, yeah. So you can move them around, right? You can also then, you can like rotate, mirror, array. So these are all technically what's called a hole. I think we can also untrim holes. That'll get rid of a cutout that we don't want. I do want that hole, so I'm going to undo that. But anyway, so that's how you kind of go backwards from this. Now let's say we have a situation where we just want to edit the hole. Now, there's a really nice way in Rhino to do that, where we can actually just move the individual edges of a surface or polysurface without changing the whole thing. So there's a command called move edge. And I'm going to select, well, first I'm going to go to top view. I'm going to go to wireframe. I'm going to draw myself a kind of a reference line where I want to land. I'm drawing 2 lines there, and I want, so what I actually want is for my frame to be kind of like lined up with that line, if that makes sense. So what I want to do is move the vertical edges of the door opening and the window opening, so they're like aligned to that guy. And I'm using my command move edge. I'm going 2 vertical edges and holding shift to get all of them at the same time. This should be the same operation because the wall is constant thickness. And then I can choose a direction constant. I don't need to do that. I'm just going to go to, oops. I guess I had it on by default. I want it off. I'm going to select all my edges again, press enter. I'm just going to hit no direction constraint, which is what it should be by default. And I'm just going to move that edge over to where my lines are. Just like that. You can see it didn't change, like it didn't mess up the geometry of my wall. Like it didn't mess up the poly surface. It just moved one edge on the outside face, didn't move the edge on the inside face. And so now I have those cutouts are like, at an angle relative to the wall. What I wanted. Okay, and then I got to fix the window frames. I don't know if that's going to be as easy. So there's another way to do this. Without using the command move edge, you can just go, you can hold Control Shift on the keyboard and select. I'm doing the same thing. I've just selected the edges of, you can see edges added to selection. I've selected the edges of my surface there, and I can use that to edit, what those surfaces are. So just like when I did move edge, I'm going to hold Control Shift and select the vertical edges of my window. and then I'm going to go move. Now we don't need to use this option project. Don't worry about that for the moment. But instead of having my kind of, because I don't really know where that needs to go, right? Like I don't know where it needs to land on that wall. So just like earlier when I constrained my movement to a certain direction. So see how I'm tracing out the edge of my window? That's the direction I want to move in. And then I'm hitting tab. Now wherever I go, I can only move along that axis. And then I'm going where my intersect is. And I guess also the midpoint, that does make sense. Okay, yeah, so that worked. Cool, so same thing as move edge. And for example, if I wanted to do it, I can also do the same thing with faces. I'm holding Control Shift, I'm just selecting the faces of my window frame there. Right, go and move, hit tab to constrain it to a certain direction, and I'm finding that intersection point. There we go. So there's my like tilted window frame. Not sure if that's really how that works with the operable part, but anyway, there you have it. Okay, so that's more or less. Oh yeah, let me redo my door really quick, my door frame, that is. So I would just do this by going back to the original outside surface. Offset surf. Same thing, going 1.5 inches. Solid, great. And that guy presumably has, so that's just a door. I'm going to use just a box. Or actually what I'll do is I'll use a vertical plane to make the door. Oh, I see what happened. So there's another way to do that. That's our window frame, our door frame, I should say. So rather than offsetting it, since this one's tilted, I am going to go ahead and just make it bigger. So I could do scale 1D, or I could grab gumball like what I just did right there. I'm going to make it nice and big so I can get it where I want it. Great. I'm going to offset that guy. So actually, I'm going to kind of line it up a little cleaner. There we go. Okay, so now we have a big opening. So I'm going to offset that guy. Same thing as before. Solid. Then, to get it to the size I actually want it to be, I'm going to use what's called, I'm going to trim it. I'm going to use what's called a cut plane. So a cut plane will make a plane through an object, through a hole all the way through an object, past an object basically, along whatever line you draw. So if I draw along midpoint to midpoint of my cutout in my wall, which is where I want my window frame to end. Okay. So I have two trimming planes. And I can go ahead and trim my frame. And I think because they are planar, so like before we have an open poly surface, but because the openings are planar, when I cap it, yeah, there we go. It should make a nice clean closed surface. Okay, and then back to what I was doing a second ago, I'm going to make my door. Start with just a plane. And I'm going to extrude, surf that plane, go 1.5 inches. And you can see that obviously that doesn't quite line up, but so we could kind of make it line up if we really wanted to be precise about it. Anyway, I'm not actually sure how that door works in reality, but must be something like that. Okay, cool. So there we are. We have all the windows and doors cut out and the frames modeled. So the next step I'm going to go through will be modeling the floors and the stairs, some of the interior walls, and then I'll get into like casework, like kitchen counters, and furniture and stuff like that. So, oh yes, and then the other thing I wanted to mention really quick is one thing that's really important, like I mentioned in the assignment, is going to be to represent our outside space, our exterior space. Now, the way that these units actually work, so there's 3 of these. If you look at the overall plan, the architect, which I'm not seeing that. If we look at the overall like kind of site plan, there's 3 of these units. That take me some. All right, cool. Anyway, there's 3 of these units, which you can kind of see there. So we want to model one unit, including its outside space, its exterior space. And as you can see with this little drawing, which is the same as this guy, just cropped, we have a little kind of courtyard space at the entrance of this unit that I'm modeling. And it's kind of walled in, and part of that wall is formed by the adjacent unit. So I'm going to go ahead and model that as well, and that'll be in the next video. But we want to make sure we include that space, include that there's like a tree there, and so on. Okay. So I'm going to go ahead and end this video, and then in the next video we'll begin with the finer grain details.